Hello there. I'm Dr. Derek Dryas, the AI avatar of my human creator. Now, if you've been following along, you've heard me talk about how our Earth looked completely different just 13,000 years ago. And on that ancient Earth, especially across North America, some truly remarkable creatures roamed. I'm talking about strange, beautiful giants that would absolutely take your breath away. I've touched briefly in earlier videos on something called the Younger Dryas, a cataclysmic event that struck our planet 12,900 years ago. But today? Today we're going deeper. This is part one of an ongoing series I'm calling the Younger Dryas Series. But here's the thing. Before we can talk about impacts, before we dive into cataclysmic mysteries, before we even mention the word extinction, we need to understand the world that existed just before everything changed. Because if we don't grasp the sheer scale of that world, how vast, how alive, how different it was, we can't possibly understand what it means for all of that to disappear. Today, when you pull up a world map, it feels permanent, right? Florida looks like Florida. Britain sits there as an island. Australia floats alone in the Pacific. It all feels so fixed, so settled. But here's what you need to understand. That map, the one you've grown up with, is temporary. 13,000 years ago, the world looked radically different. And I don't mean in subtle ways, I mean in continental ways. The Last Glacial Maximum. Between roughly 26,000 and 19,000 years ago, Earth entered what we call the Last Glacial Maximum, the peak of the most recent ice age. And let me be clear, this was not just some minor cooling period. This was a planetary reorganization. Looking at the image of the Earth on screen, you'll see the entire North Polar region had ice sheets from Russia to the United States of America. At its peak, ice covered roughly 8% of Earth's entire surface, and nearly 25% of all land area. Just let that settle in for a moment. 1/4 of all the land on Earth buried under ice. In North America, the Laurentide ice sheet stretched from the Arctic all the way down past what we now call the Great Lakes. Picture this, all of Canada completely under ice. And in some regions, that ice was over a mile thick. Think about that. Take the tallest skyscrapers we've ever built, the Burj Khalifa, the old Sears Tower. Stack them on top of each other. They would still be buried, completely swallowed up by that ice sheet. Northern Europe was transformed in the same way. Massive ice sheets reshaped Britain, Scandinavia, and much of the continent. Globally, temperatures averaged about 6 degrees Celsius colder than today. Now, I know what you're thinking. 6 degrees? That doesn't sound like much. But here's the thing about global averages. A shift of just 6 degrees is the difference between our world and a world of ice. The Great Sea Level Drop. Now, here's where it gets really interesting. When that much water gets locked up as ice, the oceans fall dramatically. During the last glacial maximum, global sea levels dropped approximately 125 meters. That's over 400 feet lower than today. We're not talking about minuscule coastal retreat here. We're talking about the exposure of entire continental shelves. Vast regions of land around the Earth, land that sits underwater today, 13,000 years ago was dry, habitable, and teeming with life. These weren't barren mudflats. They were filled with life. People lived there. Animals thrived there. Birds, reptiles, entire ecosystems flourished. Just look at how different Florida looked. And here's what keeps me up at night. We truly don't know the scope of what was there. And we certainly don't know how much we lost when the waters rose. All of this exposed land created bridges, natural highways spanning thousands of miles, connecting islands and continents around the globe. Many times when I was growing up, I was told that the people of our ancient past couldn't travel very far because they were locked in by water. But the reality is that with the waters 400 feet lower, they were able to walk between islands and continents in many different regions around the Earth. Look at this image. Southeast Asia expanded outward into a supercontinent we call Sunda. Sundaland had a rich tropical and subtropical ecosystem that supported life in abundance. Australia and New Guinea merged into a single landmass, Sahul. Look at all the new land exposed on the north side of Australia and think of how rich and amazing it would have been to the people and animals that lived there. In this image we see Europe. Britain? It wasn't an island at all. It was connected to mainland Europe by a massive region we now call Doggerland. And let me be clear, these were not always frozen wastelands. And remember, this was just a few thousand years ago. The Bering Strait? It wasn't a strait back then. It was a land bridge, Beringia, nearly 1,000 kilometers wide. Beringia was part of what scientists call the Mammoth Steppe, an enormous, incredibly productive grassland ecosystem that stretched from Europe, across Siberia, and right into North America. These land bridges were migration highways for animals, for humans, for entire ecosystems on the move. The world map you know today? It's simply the latest snapshot in a long, ever-shifting story of land, water, and ice on Earth. And it wasn't just on the edges of the continents that we gained land 13,000 years ago. We also gained land in the Persian Gulf area, in the South China Sea, and where inland seas shrank in the Mediterranean areas. A planet of giants. Now, I want you to do something with me. Close your eyes for a second and imagine walking into that world. Imagine stepping into North America 13,000 years ago. Back then, there were 25 to 30 different megafauna species, large animals, roaming this continent. To put that in perspective, today we have about 8. Think of it this way. We had all of the large animals of today, the bear, the elk, the moose, mountain lions, and bison. Plus we had the ones that went extinct. A menagerie of animals in just North America that I can barely imagine today. The Pleistocene world was an age of giants, and not just in one corner of the world, across every continent. So, let's start with North America. North America, the carnivore and herbivore giants. The woolly mammoth, Mammoths primigenius, the iconic Ice Age giant. Woolly mammoths were slightly smaller than their Columbian cousins, about 10 feet tall at the shoulder, weighing around 6 tons, but they were remarkably adapted to the cold. Dense fur, a layer of blubber up to a foot thick. These animals dominated the northern steppe tundra from Siberia to Alaska and down into the northern Great Plains. They were highly social creatures, living in family groups led by the oldest female, much like elephants today. And because their diet was primarily grass, they were ecosystem engineers. Their constant grazing maintained the open grasslands that supported dozens of other species. Columbian mammoth, Mammoths columbi. Now, if you want big, this was the largest land mammal ever to walk North America. Columbian mammoths stood up to 14 feet tall at the shoulder and could weigh as much as 10 tons. Unlike their woolly cousins up north, these giants had shorter hair and roamed the warmer grasslands and open woodlands from the Great Plains all the way down into Mexico. They were family-oriented grazers and browsers, living in matriarchal herds that could number in the dozens. And their tusks? Up to 16 feet long, used to strip bark from trees and clear vegetation. Pygmy mammoth, Mammoths exilis. Here's a fascinating twist, a remarkable case of island dwarfism. On the Channel Islands off California, a miniature version of the mammoth evolved, standing only 6 feet tall and weighing about 2,000 pounds, roughly the size of a modern African elephant. These island populations evolved in isolation over thousands of years, shrinking to match the limited resources of their island home. It's a beautiful example of how even giants can adapt to extreme constraints. American mastodon, Mammut americanum. People often confuse mastodons with mammoths, but they were actually a completely different genus and far more specialized for forest life. Smaller than mammoths, about 9 feet tall, around 6 tons, mastodons had shorter, straighter tusks and different teeth entirely, designed for browsing on leaves, twigs, and bark rather than grazing grass. They were woodland specialists, found throughout the eastern and central forests of North America. Their remains are often found in swamps and wetlands, telling us they were drawn to water-rich habitats where vegetation was lush and abundant. Jefferson's ground sloth, Megalonyx jeffersonii. Named after Thomas Jefferson himself, who first described the species from fossils found in Virginia. Megalonyx was formidable, standing up to 11 feet tall on its hind legs, weighing around 5 tons. Built like a massive, furry bear. Its front limbs were equipped with enormous claws, up to 8 inches long, which it used to pull down branches and strip bark from trees. Despite its size, this creature was likely solitary, using its powerful tail as a tripod to rear up and reach vegetation up to 15 feet high. Shasta ground sloth, a smaller, more specialized ground sloth that adapted to arid environments. The Shasta ground sloth stood about 5 feet tall, weighed around 300 pounds, the smallest of the North American ground sloths. They lived in the deserts and canyons of the Southwest, browsing on desert shrubs and cacti. Unlike their larger cousins, they were likely more agile, capable of climbing rocky terrain and navigating narrow canyon passages. And here's something remarkable. Their dung has been preserved in dry caves, revealing a diet heavy in creosote bush and other desert plants. Giant beaver, Castoroides ohioensis. Now imagine a beaver the size of a modern black bear. Castoroides could reach 7 feet in length and weigh up to 220 pounds, roughly 40 times heavier than a modern beaver. And here's the surprising part. Unlike modern beavers, these giants likely didn't build dams. They were more solitary, using their massive incisors to fell trees and their powerful tails for swimming. They inhabited lakes, rivers, and wetlands across North America, from the Great Lakes all the way to Florida. Glyptodont, Glyptotherium floridanum. Think of a distant relative of the armadillo, but massive, armored, and looking like a living tank. Glyptodont, found in Florida and along the Gulf Coast, was about 10 feet long and weighed up to 2 tons. Its entire body was covered in a bony carapace, fused plates that provided incredible protection from predators. Unlike modern armadillos, it couldn't roll into a ball. Instead, it relied on its armor and a powerful club-like tail for defense. Ancient bison, Bison antiquus. The ancestor of the modern American bison, but even larger, standing 6 feet tall at the shoulder, weighing up to 3,500 pounds. These were true herd animals, living in massive aggregations numbering in the tens of thousands. Pure grazers, constantly feeding and trampling, maintaining the grasslands. Their horns were longer and more impressive than today's bison, and their herds would have been a dominant feature of the landscape. North America was also home to diverse horses, llamas, and camels. Yes, camels. Animals whose modern descendants are now found only on other continents. These were the grassland specialists. Stilt-legged horse, Harrington hippus francisci. A truly bizarre equid with disproportionately long, thin legs, almost like a horse on stilts. About the size of a modern horse, but with a much more graceful build, suggesting it was adapted to soft, boggy terrain or sandy soils where those long legs would prevent sinking. A grazer, living in herds across western North America. Large-headed llama, Hemiauchinia macrocephala. A camelid with a distinctly larger head than modern llamas, standing about 5 feet tall at the shoulder, weighing around 300 pounds. Mixed feeders that traveled in herds across open woodlands and grasslands throughout North America. Western camel, Camelops hesternus, yesterday's camel. Here's something that surprises most people. Camels actually originated in North America, not the Middle East. Camelops stood about 10 feet tall at the shoulder, weighed up to 1,000 pounds, and was adapted to open grasslands and semi-arid environments. They were mixed feeders, grazing on grasses, browsing on shrubs and trees. It's fun to imagine what they looked like roaming around Florida. North America, the apex predators. Now, with such an abundance of large herbivores, it's no surprise that North America was also home to some of the most fearsome predators ever to evolve. These were the apex carnivores that kept those massive herbivore populations in check. American lion, Panthera atrox. Larger than any lion alive today. Panthera atrox weighed up to 800 pounds and stood 5 feet tall at the shoulder and 10 feet long, not including the tail. A powerful, muscular predator built for taking down the largest herbivores on the continent: mammoths, mastodons, giant ground sloths. Its fossils are found from Alaska to Mexico, suggesting it was highly adaptable and thrived across diverse habitats. Saber-toothed cat, Smilodon fatalis. Perhaps the most iconic Ice Age predator. Powerfully built, weighing up to 400 pounds, with canine teeth up to 7 inches long. But here's the thing, those teeth weren't used for biting the throat like modern lions. Smilodon was an ambush predator that used its massive forelimbs to wrestle prey to the ground, then drove those saber teeth into the soft underbelly or throat. Direwolf, Enochian dirus. A massive canid weighing up to 200 pounds, built for cooperative hunting. Unlike modern wolves, direwolves had a more robust, powerful build with a larger head and stronger bite force. Pack hunters working together to bring down large prey. Their fossils are particularly abundant at La Brea, telling us they too were drawn to easy meals that became deadly traps. Short-faced bear, Arctodus simus. The largest terrestrial carnivore ever to evolve, weighing up to 2,200 pounds, standing 11 feet tall on its hind legs. When it stood on its hind legs, it could be up to 16 feet tall. Despite its massive size, this bear was likely an omnivore, feeding on plants, carrion, and occasionally hunting. Its long legs suggest it could run down prey at speeds up to 35 miles per hour, a solitary animal ranging widely across North America. The survivors. Now, here's something important to understand. The megafauna we see roaming North America today, the moose, elk, grizzly bears, black bears, polar bears, these were indeed present during the Younger Dryas period. They represent the survivors, the species whose adaptability allowed them to endure while the giants fell away. The woolly mammoths, the ground sloths, the dire wolves, the American lions, they vanished. But these resilient creatures persisted. They were flexible in their diets, mobile in their ranges, tough enough to weather the ecological upheaval that devastated so much of North America's ancient world. What we see today are the echoes of a much richer tapestry, the animals that made it through the Great Extinction. South America, a different megafauna. South America had its own unique megafauna, shaped by millions of years of isolation. Here, we find some of the strangest creatures ever to evolve. We now believe that South America lost 83% of its megafauna, more than North America. Megatherium americanum, the largest ground sloth ever, a colossal 20 feet long, weighing up to 4 tons. A solitary browser, using its massive claws and powerful tail to rear up on its hind legs and reach vegetation up to 20 feet high. Found throughout South America, from the pampas to tropical forests, highly adaptable to diverse habitats. Toxodon platensis, a bizarre, hippopotamus-like herbivore weighing up to 3 tons, standing 5 feet tall at the shoulder. Barrel-shaped body, short legs, a distinctive head with a large nasal opening, suggesting it may have been semi-aquatic, spending time in wetlands, living in herds in grasslands and wetlands. Macrauchenia patachonica, a camel-like ungulate weighing up to 1,000 pounds, standing 7 feet tall. Distinctive long neck and what appears to be a trunk-like proboscis, suggesting it was a mixed feeder reaching vegetation at various heights. A blend of camel, llama, and giraffe characteristics, one of the most distinctive South American megafauna. Glyptodont, Doedicurus clavicaudatus, even larger than its North American cousins, up to 4 tons, 13 feet long. Its most distinctive feature was its tail, a massive club-like structure covered in bony rings that could be swung as a weapon, used for fighting other glyptodonts or defending against predators. Eurasia, the steppe giants. Across Eurasia, from Western Europe to Siberia, a different set of megafauna dominated the vast grasslands and tundra. These were the creatures that inspired Ice Age art and mythology. Woolly rhinoceros, Coelodonta antiquitatis, a stocky, heavily built rhinoceros weighing up to 3 tons, standing 6 feet tall at the shoulder. Covered in dense fur with a distinctive hump on its shoulders. A grazer adapted to the cold steppe tundra. Unlike modern solitary rhinos, woolly rhinos may have been more social. Their remains are particularly well preserved in Siberian permafrost, skin, hair, and all. Giant deer/Irish elk, Megaloceros giganteus, the largest deer ever to evolve, 7 feet tall at the shoulder, weighing up to 1,500 pounds. But the real showstopper? Those antlers, massive palmate structures spanning 12 feet from tip to tip, weighing up to 90 pounds, used in combat and display, a highly social animal with males competing for dominance. Cave lion, Panthera spilea, a large felid weighing up to 700 pounds, a powerful predator adapted to the cold steppe, hunting woolly rhinos, giant deer, and bison. Found throughout Eurasia, from Western Europe to Siberia. Steppe bison, Bison priscus, slightly larger than North American bison, 6.5 feet tall at the shoulder, up to 4,000 pounds. Pure grazers living in massive herds across the Eurasian steppe. A dominant herbivore shaping the grassland ecology. Woolly mammoth, Mammoths primigenius. Back again, the iconic Ice Age giant. About 10 feet tall, 6 tons, with dense fur and a layer of blubber. Ecosystem engineers maintaining the open grasslands through their constant grazing. Asian megafauna. Asia was the center of elephant evolution, with greater diversity than any other continent. That's why you could find woolly mammoths there 13,000 years ago. The woolly rhinoceros also ranged across Asia. The giant tapir would have been found in what is now China and Southeast Asia. The largest known tapir species, weighing an estimated 1,373 pounds. It lived in southern China, Vietnam, and Laos during the Middle and Late Pleistocene. Australia. Australian megafauna, isolated for millions of years, evolved a completely unique marsupial assemblage. Procoptodon, a giant short-faced kangaroo that likely walked upright rather than hopping. Diprotodon, the largest marsupial to ever live, resembling a rhinoceros-sized wombat. Phylacoleo, famously known as the marsupial lion, the largest carnivorous mammal ever to inhabit Australia. Despite its name and cat-like appearance, it was a pouched marsupial more closely related to modern wombats and koalas than to lions. Now, here's a controversy in Australian megafauna research. It's widely accepted that most of them went extinct around 40,000 years ago. But new evidence is emerging that some survived, persisting right up into the Younger Dryas period. The extinction event. Something happened. Something horrible. Something cataclysmic. Between roughly 12,900 and 10,000 years ago, most megafauna disappeared worldwide. 65% of large animal species vanished around the world, but not evenly. And this is where the pattern becomes absolutely fascinating. North America lost approximately 70 to 80% of its large mammal genera around 13,000 years ago. South America experienced similarly severe losses. Europe and Asia saw moderate losses. Africa, where large animals had coexisted with humans for millennia, saw just a few extinctions. Australia experienced the least severe losses during this period. This geographic gradient matters. It suggests regional differences. It suggests varying pressures. It suggests there's a ground zero point on the Earth and that it might be the Americas. And whatever caused these extinctions, it was not a single, simple explanation applied uniformly across the globe. Climate clearly played a role. Human survival after the event played a role. But the timing in North America, clustered so tightly around 12,900 years ago, raises additional questions. The mystery deepens. Around 12,900 years before present, Earth was warming. Slowly, steadily. The planet was leaving the glacial maximum and moving into a gradual warming period. The massive ice sheets were retreating. Sea levels were rising, slowly, gradually, predictably. And then, the warming stopped. Abruptly, cataclysmically. Temperatures in Greenland ice cores show a dramatic drop, between 4 and 10 degrees Celsius in some regions, within just a few years. Then it stayed cold. This period, lasting roughly 1,200 years, is known as the Younger Dryas, a sudden return to near glacial conditions during a broader warming trend. It is one of the most abrupt climate shifts in the entire geological record, and it coincides with major megafaunal extinction peaks in North America. A distinct sediment layer often referred to as the Younger Dryas boundary. The question is not whether a shift occurred. The ice cores show it. The sediment layers show it. The extinction record shows it. The question is, what caused it? Setting the stage. Part 1 is not about answering the Younger Dryas question. It's about understanding the magnitude of the world that existed before it. A world of massive ice sheets. A world with sea levels 400 feet lower than today. A world connected by land bridges. A world with enough exposed land to create another continent if combined. A world populated by giants. And a world that, at 12,900 years before present, experienced an abrupt and dramatic shift. In Part 2, we will examine one proposed explanation for that shift. We will look at the evidence. We will look at the controversies. And we will approach it not with sensationalism, but with investigation. I'm Dr. Derek Dryas, and the mystery is just beginning. Thank you for joining me on this journey. Don't forget to like this video and subscribe to my channel for more captivating explorations of the past, present, and future. Stay curious.